Hello, distinguished guests, partners, supporters, and friends. Welcome to the Computer History Museum 2021 Fellow Awards. It's wonderful to have you with us for this exclusive backstage portion of our program. I'm Dr. Talithia Williams, a mathematics professor at Harvey Mudd College, and I'm super excited to be your co-host for tonight's celebration. Now, since 1987, the CHM Fellow Awards have honored distinguished technology pioneers, unsung heroes and legends for their significant contributions to the advancement of computing and the evolution of the digital age. Now, I want to give a special shout out to all of our fellows from previous years who've joined us tonight. If you're a CHM fellow, be sure to tell us in the chat. And the chat is not just for fellows. We invite all of you to add your voice via chat or through social media with the hashtag CHM Fellows. We want you to be a part of this conversation. Well, now it's time to get started. So please join me in welcoming CHM President and CEO, Dan Lewin.
Great. Well, thank you, Talithia. It's great to have you as a friend of CHM and co-host tonight. I'm excited to see so many friends of the museum backstage at our second 2021 virtual CHM Fellows Awards. Welcome. Thanks also to our outstanding trustees, our dedicated staff and volunteers, and our valued partners and supporters who advance our mission every day. We appreciate your passion, expertise, and energy. And thank you all for being here tonight. It's exciting to gather in honor of artificial intelligence and robotics pioneer Raj Reddy. And with us to join Raj in conversation is the former president of Stanford University, who's currently a professor of computer science, the director of the Knight Hennessy Fellows Program, and the chair of the tech firm Alphabet, John Hennessy. Raj, John, it's great to see you. In fact, it's really only fitting and appropriate that Raj should make his entrance on a robot. And I want to thank you both for joining us for this special backstage conversation. We're looking forward to hearing firsthand the stories and learnings from Raj's amazing journey. And maybe even more important, to hear Raj's thoughts about what's ahead and how AI can help solve some of today's most pressing global problems. Over to you, John. Raj.
Thank you, Daniel, and congratulations, Raj. I've had the great good fortune of knowing Raj for many years. He is the very first PhD from computer science at Stanford. So this is a great privilege for me to have this chance to talk to you. Raj, why don't you start by telling us a little bit about your first encounters with computers? What were they like? How did you get excited about using them? What kind of experience was it?
Yeah, the first time I got introduced to computers was in 1959. I was a graduate student at University of New South Wales in Australia. So my advisor said, I'm going to the computer center, why don't you come and join me? And I said, sure. And there I saw this huge vacuum tube computer taking up a big room. And the only input it had was punch cards. You typed in, and every program was a brick. This is a bunch of punch cards. You stack them together. And you did computation in stages, did a little bit of computation, then print out, punch the cards out. It only had about 1 kilobyte of memory. That too, it was not a drum or any of those things. It's a mercury delay line memory at that time. And but it did have a CRT display. And it would actually, somebody figured out how to use play music on it. And so you could actually hear the music of whatever it is thinking. So it was quite exciting, but it was kind of awesome at that time. And by the way, it was the computer, it was called Deuce by English Electric. It was designed, it is a follow-on to ACE. And if you remember the history, Alan Turing designed an architecture called ACE, a computing engine, and at Manchester, they built variations of it, but this was the first one that was commercially available that lots of people could buy. And it had one and it had a high-level programming language. It had only one data structure. It was just a matrix. Everything was a matrix. It was great to do that at the time.
Yeah, I think people don't realize how primitive these systems were. Not only small amounts of memory, but if you were to compile a program or something, first put the compiler, stack of code for the compiler on the card deck, and then the program you wanted to compile. It was, and turnaround time was long.
Right.
So how did you go from that early interest in computing to your interest in artificial intelligence? Because that's a really big jump, especially at the time you began the field.
After I graduated, I was lucky to be hired by IBM in Australia. And I was there with IBM for 3 years. And during that period, I would read, articles that I would come across, and also there would be visitors, from IBM research in Yorktown and so on. So I read about all the early work, or not all the early work, many papers by Newell and Simon and McCarthy and Minsky, Stepford, all of those things. And that kind of said, this looks like an interesting thing I would like to do. And I applied to only CMU, Stanford and CMU. And I ended up at Stanford. And so it was, you will remember it, you may remember it. I don't know if Polya Hall is still there. We were in Polya Hall, and George Forsyth was the department head. And it was a small department, and about half a dozen faculty members at the time.
Yeah, it was a tiny department. I mean, the field was so new. There were no undergraduate majors.
Right.
There was nothing. So
yeah,
people were coming into it. What was your undergraduate major in?
In my undergraduate major was in engineering, civil engineering.
Civil engineering.
And my advisor took me there because they were doing structural analysis in computers, big, numerical analysis. And so when I started with IBM, I wasn't doing any of that. I was mainly a systems programmer type, and what they called me applied science representative or something. But that's all I was doing. So when I was thinking about graduate programs, I just decided, rather than do a PhD in civil engineering, I will do it in computer science. But there was no computer science program at Stanford when I arrived there in '63. And so I ended up getting admitted to the operations research program because they had a PhD program. And then McCarthy said, this was in 1964, look, they approved the formation of the department, so now we'll have a department. That was in January 1965. And so I just stayed on. That was, it was very interesting.
Well, you came to the department at an incredible time because Knuth, McCarthy, Feigenbaum, I mean, it was just Forsyth. It was really Gene Golub. It was an explosive time in the field.
Knuth came a little later. But
he came in '66, I think.
Knuth was, Forsyth was trying to recruit him right from the time I was early on, but he couldn't. He had other commitments. So he only came in '68 or '69. But, that was early, early history from there.
It was. Well, when you came to Stanford as a PhD student, you had the opportunity to work on a DEC PDP-1. I know the university had just bought a different kind of computer, but we thought it might be interesting for you and us to look at a video that reminds us what those computers were like. So let's roll the video.
In 1959, computers were large, expensive, and rare. That same year, Digital Equipment Corporation, a young company based just outside of Boston, unveiled its first computer, the PDP-1. The PDP-1 was an early, iconic mini-computer, a radical design change to smaller, less expensive computers. Only 53 were made. A few went to universities like MIT and Stanford. Now, it won't surprise anyone that one of the first things that transpired on the MIT PDP-1 was the world's first video game, Space War. The PDP-1 was remarkable. It had a paper tape reader and punch to store and read data onto paper tape, a typewriter to type in and print out data, a cathode ray tube Type 30 display that allowed programmers to view and edit programs and games. And finally, it had a light pen connected to the monitor to point at objects or draw directly on the screen. The PDP-1 was a game changer. It captivated an early generation of engineers with revolutionary real-time capabilities, interactivity, live graphic display, and even sound. It launched hacker culture. Rolling Stone declared, "Ready or not, computers are coming to the people." In 1963, when Raj Reddy arrived at Stanford to start his PhD, so did a brand new PDP-1 to the AI lab led by AI pioneer John McCarthy. McCarthy, Raj's thesis advisor, suggested that perhaps he could do a class project using the new PDP-1's analog to digital converter, which allowed for analog signals like speech or music to be input into the computer. Raj got to work. He'd arrive in the evening after everyone else had left, and he'd work through the night 7 days a week just so he could have the PDP-1 all to himself. As captured in his oral history for the museum, he said,
And I thought I died and went to heaven.
what Raj began as a class project on the PDP-1 blossomed into his PhD dissertation and the first continuous speech recognition program,
Pick up every small block.
as well as the start to his life's work. Today, there are only 3 PDP-1s left in the world, 1 restored to full operation, and all are at the Computer History Museum. This PDP-1 is one of over 100,000 artifacts in the museum's collection.
Well, that's amazing, Raj. You look at those machines, and I thought the story of you, which I had the same experience. Late at night, you could get your hands on the whole machine. Students today own their machines, right? But in those days, that's how you got the work done.
Exactly. I was there for 12 hours a day, like 8 to 8 or something. The only other person that would come by is, you would remember him, professor of music called John Chowning.
Oh, yeah.
He wanted some cycles.
Yeah.
So we worked out some arrangement. So anyway, to me, in retrospect, looking at it now, that was the beginning of computers. Before that, computers would only be used for number crunching, numbers, computation. All of a sudden, there was the beginning of computers that can see and hear and do things, act. That is the beginning of the kind of, that is the forerunner to me of the smartphone, which had cameras and microphones and vibration, all kinds of things that were not conceivable. And it was all on a small form factor. And that took, 30, 40 years.
Well, in fact, late at night, it was a personal computer, albeit a pretty expensive one, but personal computer for you.
Exactly. But they did build a time-sharing system for it, so more people could use it. But it was, Steve Russell built the time-sharing. That's the same guy that did the space war.
Right.
He was the person that did it.
Well, McCarthy was a big advocate of time sharing. And by the time I got to Stanford, we had just started putting in a lot of time sharing resources for students at large. So tell me about your first attempts at AI. I mean, this was a young field and the problems seemed almost insurmountable. They must have, given the computer power of the time. How did you really think about that? How did you get over the hurdle and really begin to make progress?
We didn't understand how much computing power will be needed to get high caliber recognition. Somehow we were all optimistic and we thought it'll all be done in 10 years or 5 years or something. But slowly, as you began to try to make computers understand or recognize speech, and that happened in the early 70s under a DARPA program called Speech Understanding Systems. Licklider was, in fact, also back at DARPA at that time. And the Speech Understanding program is the only program that had a specific 5-year goal at that time. You have to do 1,000-word vocabulary connected to speech in this, real time or something like that. And it was not at all clear it could be done, but we did it. And in fact, there are some videos on YouTube that show Harpy, and here's a systems that do that. And that was when we understood that we are very far from being able to recognize what we call USSOP, unrehearsed spontaneous speech from open population. And that is still not completely there.
Yeah.
For example, if you turn on YouTube closed captioning, you will see the large number of still words that it misses. And the new GPT-3 might fix some of them, but we don't know.
Yeah, still have a ways to go. So I want to, those early times are fascinating, but I want to talk a little bit about your role as a mentor, a leader. You have a reputation for being an incredible leader, not only of large projects, but also a personal hands-on mentor. So my first question is, did you have a personal mentor? Did you have somebody who helped inspire you as you went through your career?
Yeah, I think I was just imitating Newell, Simon, and Perlis. They're like that. They were very empowering and easy to access, easy to work with, and easy to get things done. I almost never heard no from any of them. I would go and suggest some crazy thing, and they would say, well, let me see, maybe we can make it happen. That's the kind of thing that's very important in research environments, and that is those are, if I had to say, there were mentors that are kind of helped to kind of form that thing. It would be Alan Perlis. Alan Perlis was the first Turing Award winner and the first head of the department at CMU, and of course Newell and Simon were the founders of the field of AI and cognitive psychology. So they were all, kind of major figures in their own right, but somehow they figured out how to subsume their egos and work together to build a high caliber place. And they were also very, funny, interesting people. I remember Perlis. I went to Perlis and said, Alan, why don't you have a department? I've never had a faculty meeting. When are you going to have? He says, I never have faculty meetings. It's a waste of time.
Many of his colleagues agreed with him, no doubt.
And the same thing with Simon. I would say, Herb, what do you think of X? He says, I never read newspapers or magazines or anything because they're a complete waste of time. And he followed it, except I said, but it can't be that. People watch TV not because they want to waste time, they want entertainment. But he had his own separate entertainment. They're very interesting personalities, but nevertheless, it kind of, you learn by observing how empowering they are. We had this thing called reasonable person principle. You kind of let people do anything they want. If they screw up once or twice, it's okay. You kind of say, it's a reasonable person would have done it, therefore. And after that, you might kind of tell them not to do it again. But
yeah, it's a great principle because it assumes people are coming from a valid point and not that they're out to do something negative. And it helps settle a lot of battles. So Raj, you've led a lot of great projects. What advice would you give to a young person that'd like to do work like you've done in robotics or in speech recognition? How should they think about being a leader?
Yeah, the biggest problem I think we all have is how to pick a new project, right? And usually we shy away from things that seem impossible. And so I think my recommendation would be think out of the box. Doesn't matter, even if you fail, you will achieve a lot of things that would be successful. So you must, kind of think out of the box to make things happen, and also be sufficiently humble to realize even an undergraduate might have a pretty good idea that, you shouldn't completely reject things just because an undergraduate said it so, And those are the kinds of things I think that worked out at CMU.
Well, now we're going to hear from a couple people that you've served as a mentor for in their work on Dragon systems. So let's roll the video from the Bakers.
Thank you, John. Thank you so much for allowing us to be part of this great honor to Raj. He has been so important, not only to us personally, but to so many others, and he richly deserves this honor. We first met Raj as graduate students from Rockefeller University. We had been asked to come out and give a couple of talks on our thesis work, actually instituted by Alan Newell. And by the end of the day, after we gave our talks and chatted with various people, Raj invited us to transfer out so we would have access to more computer facilities and be able to have as collaborators other people working on speech at Carnegie Mellon. So we did, and we're very glad we did. It was a wonderful experience, but it wasn't just a wonderful experience for us. Raj is really the epitome of empowerment for so many people. And although we were very certain about the areas that we wanted to pursue, there were other graduate students who weren't, and he helped steer them to be as successful as possible. And with his students and his other collaborators, he was a tremendous, and has been a tremendous catalyst for change and force for good, as can be seen by the dispersal of his many contacts and all the things they have done worldwide. He's a very shrewd judge of character, and in his very unassuming, collaborative fashion, manages to make great things happen in many domains. I'll let Jim talk a little bit about what our experience was. Jim.
So I will talk specifically about empowerment as my personal relationship with Raj while I was a graduate student. I was working on a mathematical model that's called a hidden Markov process model, and I thought it could be used for speech recognition, which was a major project that Raj was supervising, a speech recognition project at Carnegie Mellon at the time. And has continued supporting that through his career. But my approach was controversial within AI. I had not been working in AI, and I was approaching it as a math major, and it was basically a mathematical model. And AI in the early 1970s was still trying to show that it could be used for things, that computers could be used for things other than just doing a lot of computation. Computers not just can do arithmetic a million times faster than people, but it could do things that people regard as signs of intelligence. And it was somewhat controversial. If I just used a mathematical model, was that really AI or not? But Raj was very open-minded, and he warned me that, what I was trying to work on might not work. It had never been done before. And I think maybe he suspected that maybe it would fail, but he would empower me and let me try it. And I tried it, and it worked. No one had done it before, but it turned out IBM Research Group was also doing it at the same time, but we didn't know about each other. And together, probably more due to publicity that IBM got, but in any case, hidden Markov process modeling, which was the technique that I was using at Carnegie Mellon, did succeed, and it grew to become actually the leading technique in speech recognition for several decades. But this is just a symbol of one thing that Raj did for one student. He did empowerment for all of his students, but much more than that, he took a long-term vision in AI and had looked at grand challenges and at the long-term future of AI as a contribution to humanity. So he affected not only hundreds of people that he worked with directly, but thousands, tens of thousands of people that he inspired, and millions of people that were affected by projects and initiatives that he initiated and inspired.
Congratulations, Raj. It's a great day.
Well, thank you, Janet and James. That was great. Raj, anything you want to add? Corrections? Any perspective on this?
Yeah, Jim was mild, and I said, Jim, I know hidden Markov models. At Stanford, I was the only one that got an A+ in statistics, but it's not going to work here. But if you want to do it, why not? Let's see. You may waste 6 months of your time, but I think the great thing about it is, even after 40 years, that is the model all the speech recognition systems are using. In the deep learning comes in, but it's not complete architecture. Deep learning is used mainly to learn certain things, but hidden Markov model is still embedded there in almost all the systems.
Yeah. So we want to shift gears now and talk about your role in using technology in service to society and the work you've done. For example, in the 2000s, you pioneered a project called the Million Book Project to try to get books and digital content out there, creating inclusion and making content available to people. Tell us about some of that work that you did on that project, or I know you've also done work with Rajiv Gandhi University in India. I'm eager to hear about your work in this role.
So the Million Book Project was in fact a very exciting, interesting experiment that has the beginnings going again back to John McCarthy. When we saw we were all producing theses, students were producing theses on the computer, and he said, why don't you put it on the computer and then let people access it? And then 10 years later, when I was at Centre Mondial, I invited John to kind of come and help us to create a digital library project. And at that time, the scanners were still not that good. So we even decided it's okay to simply manually type in the books that we want to have online. And it turns out, if you look at the millions of books, we estimated like maybe there are 100 million books. The number of books that are that are still routinely read are a handful, whether Shakespeare or Jane Austen or Walter Scott or something. And so we said maybe there are 10,000 good books that everybody would want to have. And later on, the Gutenberg project, people did exactly that, except it was all simple text. That was not very satisfactory. So about by mid-90s, we began to have scanners that could be used for high-speed scanning of books and so on. In 1995, I remember we had a meeting, a digital library meeting. Before that, we used to call it electronic books, right? And Vint Cerf and Bob Kahn were there. And Vint came up with an idea, digital library. That's the first time I heard the name digital library in 1995. And now it's kind of routinely used by everybody. So I think it's, we scanned all the books. We stopped, wisely when Google started scanning books because they had much bigger resources and a lot more things to do. But even they ran into this damn copyright problem, which unfortunately is only relevant for a very small number, maybe 1% of the people. But everybody comes under the thing. And so a lot of orphan books and things that would be interesting if they were online, but they were under copyright, so nobody wants to scan it because of the liability issues and all kinds of things. So that problem is still there. And I think, it's something we ought to figure out how to resolve.
Well, copyright law, unfortunately, was written many years ago when a book was a hard copy thing that was printed and very expensive, and we never dealt with the changes that technology wrought
It is mainly the fact that lots of things that are published that are lost forever, and magazines and newspapers, especially newspapers. I would love to be able to go read, newspapers of the day on many important events of the world. Maybe you get to see the archives of New York Times, but if you don't read English and you want to see it in Chinese or Hindi or something, they're not there. And it would be good if we can capture them.
You know, and one of the great ironies, of course, the searching digital libraries was the original inspiration for Larry Page to begin the work that eventually led to the Google search engine. So it's these grand challenges, like building a really high quality digital library, the challenge of building a vehicle that could drive autonomously through the desert. These great challenges really do push the field forward.
Yes, very much so. There are still a lot of things we'd like to do, but we don't know yet how to do. And but they certainly help to the thing. The one thing we did do was Alan Kay was responsible for getting me involved in it, is to set up the Centre Mondial in Paris, which in 1980 tried to provide the access to technology for people who would otherwise not able to see or hear or do things. And it was possible even then to think about how healthcare or education could be enhanced through the use of information technology. Nicholas Negroponte and Terry Winograd and Alan Kay were right at the forefront of it.
Well, speak of Alan, we're now gonna hear from Alan. He's a CHM Fellow, of course, a faculty member still at UCLA and works on the Viewpoints Research Institute. We're delighted to have you here tonight, Alan, to give us some insight on Raj's work.
Thanks, John. It's a great pleasure to be part of the celebration for inducting Raj Reddy, my old friend from more than 50 years ago, into the Computer History Museum Hall of Fellows. I think about Raj, there are three really unusual things that need to be mentioned. First, he's a world-class research scientist, and this is recognized by his Turing Award, which is sometimes called the Nobel Prize of Computing. But even rarer are people who can run world-class research groups, and he's done this a number of times over many years. And even rarer still is this idea of research manager. I think this is the hardest thing to do well in computer research, and it is certainly unusual for somebody who is such a good research scientist to also be able to handle this much larger, much more complicated job. And Raj has been stellar at all of these over the years. And I should mention that in the early 80s, I was approached by Jean-Jacques Servan-Schreiber, who was trying to start a large worldwide research community operating out of France to help the third world deal with the transitions of the 20th century. And Jean-Jacques contacted me, and I gave him a list of prominent computer people who I thought would be very interested in helping in this project. On that list was Raj Reddy, and he in fact was one of the major contributors to this project, which is called the Centre Mondial, the World Center for Human Resources. So all in all, I think inducting Raj into the Hall of Fellows is long overdue. And it's great to have him be a part of it because in many ways, the Computer History Museum Hall of Fellows is the most representative of far-reaching ideas of all of the honors you can get in computing. It's wider, broader, and deeper than, for instance, the Turing Award. It has many more kinds of people inducted into it. And it's so wonderful that Raj will be part of this starting now, I guess. Thank you very much, and congrats, Raj. I hope to see you again soon sometime. Bye-bye.
Thank you, Alan. Well, any thoughts on Alan's message there, Raj?
No, Alan has always been a role model for many of us of thinking out of the box. He was the guy in 68 or 69, came up with the idea of Dynabook. 20, 30 years later, now every one of us uses the laptops of the kind he talked about. And it's also, he has done a number of things in programming languages like Smalltalk and all of the things. But the thing that to me is impressive is his broad range of interests. He's an accomplished musician, among other things. And so it was good that we were part of a team together to try to do something good in the 80s. And,
well, the two of you are two people I always think of who think about the future, who inspire us to go forward, and who try things that many people wouldn't try because they think they're too hard.
That is true.
So I'm interested, Raj, in what are you really excited about seeing happen in the AI field now? I mean, we're standing on the cusp of what, with deep learning, really a remarkable revolution. What do you see as the big opportunities going forward?
Right. So I think the opportunities that are waiting to be harvested are cars that drive themselves. I know there are still problems with them. I know there are software issues and so on. However, even now, the caliber is such that they would eliminate 80% of the accidents that human beings would get into. So having a man-machine symbiosis or human-machine symbiosis, where computers kind of take over when a human being is trying to do something stupid, and the human being can override the computer if he thinks that he wants to do it in a certain way. And there are some ethical questions saying, supposing I'm drunk, I'm trying to override the computer, what would you do, kind of thing. Looking at other unsolved problems, that we've talked about this problem of, can a computer read a textbook and answer the questions at the end of the chapter? And it's turning out, even now, it's still a very hard problem. And more recent advances in language modeling of transformers and GPT-2, GPT-3 is making a huge impact on it. And so much so, Allen Institute for AI under Oren Etzioni and Peter Clark and so on, they have been working on this problem. About 5 years ago, when they took, I said, forget about taking AP biology, just take 8th grade science exam or anything, and to see if you can actually answer those questions. And it turned out the system they had in 2015 or 14 got a F grade. It failed, got 50% or something. And it took them 4 years of looking at, most of the issues were not of deep intellectual things. It's simply their ability to understand common sense terms in language and interpreting them. So for example, if you said, go to the bank, you don't know whether you were talking about a bank with money or a bank of the river or something. And with the context, you can say what kind of a bank you're talking about. So that's what is being involved. So recently, about 2 years ago, I think, they showed that they're able to get an A grade on the 8th grade test using the language modeling advances that happened in the last 5 years. Now it looks even better with GPT-3. So we have to wait and see. So the people at OpenAI are doing a great job. And so we need to figure out a way of encouraging people like that and other activities like that. So I think that's where we need to go.
So Raj, what do you think about this problem of integrating AI systems with people? Because I know one of the problems that is existed for the cars is people break traffic laws all the time. And the cars don't expect people, autonomous vehicles don't expect people to break traffic laws because they don't break them. How do we think about that integration?
This is the thing I think that is waiting to be solved, the man-machine symbiosis. That is, if two people are collaborating together, forget about a man and a machine. If you and I, it's like, those races where they tie your legs together and you have to run. You can't, it's a complicated issue. Each person wants to do something different. The same is true with computer and so on. So all you can do is you can say, human being can override. If you do that, and sometimes if the human being is drunk, he should not be overriding. So the question is, how do you design systems so that they are much more omniscient and understand what the situation is, so that they can actually help with the thing, So man-machine systems, that is the hardest thing, that we have. It's obvious to human beings when we see something, but building systems that will also understand and do things, the common sense things. There are a set of things, I think they're called Winograd schema, after Terry Winograd, where they have made up hundreds of sentences, where by just changing one word, the whole sentence meaning is changed completely. And how do you, in order to understand why the meaning is changed, you need to understand the world and common sense about what happens in the world. And so there are, things that still we're far away. I'm not sure when we'll have any kind of AI at all, maybe 1,000 years or something. But right now, I don't think we should worry about computers taking over the world or robots taking over the world.
No. Well, Raj, this has been a really great discussion. Congratulations. This is really a well-earned honor. And we wish you best wishes. And I can't wait to see you in person soon.
Thank you, John. It's great to see you again. And we'll see you again a little later.
Okay. I'll turn it back to Daniel.
Right.
Thank you, John, and thank you, Raj. That was fascinating discussion. You covered so much ground. As we close this backstage portion of the program, I'd like to express appreciation to our education sponsors, Tech First, the KLA Foundation, and Oracle. And a special thank you to our headline sponsor, Accenture, for helping make possible the 2021 Fellow Awards series, not only tonight, but throughout this year. For 8 years, Accenture has supported this important program and helped capture and share the stories of our remarkable fellows. I hope the conversation we heard tonight inspires you to think about how tech can serve humanity. So as you may have already seen on our virtual platform, we are inviting you to share your voice by recording a video. As an example, we asked Emma McGugan, Global Lead of Intelligent Platform Services at Accenture, to share her thoughts. Let's hear what she has to say.
It's pioneers like Raj who have really created this opportunity, building followership, building teams, opening doors, challenging our thinking. And it's with great excitement that I learn of his recognition. And it's with even more excitement that I think we all as leaders have this unique opportunity and this unique, maybe dare I say it, obligation to empower others.
Thanks, Emma. After tonight's show, we invite all of you to join Emma by recording a video on our event platform.